start a new problem. Okay, a square lamina or square plate. Okay, in the previous class we discussed lamina, plate, plane. So three terms will convey the same meaning. Okay, here a square plate of 30 mm sides rests on HP such that one of the diagonals is inclined at 30 degree to HP and 45 degree to VP. Draw its projections. Okay, in all previous problem, so they gave the given lamina is resting on side. Okay, if you consider first problem, equilateral triangular lamina 25 mm sides lie with one of its edges on HP. So here resting on HP with one of its sides edge both same. That's why we are taking resting side towards right. In the previous problem also resting side towards right and corner towards left. Here also resting side towards right, corner towards left. So here also resting side towards right. In this problem, a square plate of 30 mm sides rests on HP such that one of the diagonals is inclined at 30 degree to HP and 45 degree to VP. Draw its position. So here in the problem, they have not specified whether it is resting on edge or corner, but we have considered it as resting on corner. The reason is, so here we should satisfy two conditions. One is the one of the diagonal. Okay, in a square there are two diagonals. So AC and BD, there are two diagonals. So out of these two, one of the diagonal should be inclined at 30 degree to HP and 45 degree to VP. So that means in order to make this diagonal inclined at 30 degree to VP and 45 degree to 30 degree to HP and 45 degree to VP, initially we must be able to draw true length of the diagonal. Okay, when you are able to see true length of the diagonal is when it is parallel to plane of projection. When the diagonal become parallel to XY line, then only you can represent true length of the diagonal. Okay, instead of like this, if you draw a square, okay, in this manner, like this, okay, and if you draw two diagonals, now, okay, these diagonals are inclined. If diagonals are inclined, you cannot get the true length. Okay, for that reason, even though in the problem it is not given that it is resting on corner, if you want to make a diagonal inclined to HP and VP, you should consider it as resting on corner, because if you make it resting on corner, then only the diagonal become parallel to VP and HP. So then you can get true length, okay, in top view and in front view. So initially, so similar to previous problems, so here also I will keep square lamina on HP such that the resting corner is towards right. Okay, in this orientation, I will keep the complete lamina on HP so that the lamina become parallel to HP. The view on HP, that is top view, is a regular square. Okay, so first I will draw the top view. Then if I look from front, so for front view, this is the position. This is the position of the observer. For front view. For top view, this is the position of the observer. So if I look from front, so I can project A, then here, so D is visible, B will become invisible. If you keep a square lamina, okay, parallel to HP and perpendicular to VP, you can see only the corner near to the observer. D is visible, B becomes invisible. So this invisible corner should be represented within the brackets. So that means point B is invisible if you look from this direction, that is from front. Next, C. So you will project the points and you will get the front view. Next, so C dash A dash is nothing but that is the diagonal. So now now the diagonal is parallel to both HP and VP. Okay, next. So I will make this diagonal inclined at 30 degree to HP. So here you have true length of the diagonal. 30 degree is also true inclination. So you will make it inclined at 30 degree. Okay, then you will draw the front view, then project the points and get the top view. Okay, so using SolidWorks, I will complete the first two steps. Then we will discuss about the last step. Okay, if you have any doubts regarding first two steps, you can ask questions. Okay, I will consider the same problem on SolidWorks. Okay, later I will give these two questions as classwork. Okay, so that we should practice how to construct using drawing instruments on sheet of paper. Okay, so first I will draw XY line. Next, I will name it as XY. Okay, next. So here we should draw square such that it is resting on corner since we want to make diagonal incline. So for in order to draw square, okay, it is very important. Otherwise, so we have discussed. Okay, some of you are committing mistake while drawing regular polygon. Here also the orientation is like this, but interior angle still it is 90 degree. Okay, you must be very careful while drawing square in this orientation. I have seen students committing mistake. Instead of drawing square, they will end up with drawing rhombus. Okay, you should not do that mistake. First, draw a horizontal line. It is just for reference. Okay, then you know the length of the side. Okay, it is 30. So draw first horizontal line, next inclined line, a line inclined at 45 degree. Draw a line having length 30 mm. Okay, and this angle should be 45. This is the first step. Okay, for drawing this line, use protractor. Measure 45 degree angle and using scale draw a line having 30 mm length. Okay, this is the first step. Then after that, don't use protractor. Okay, now use compass. Okay, take this as center and radius as 30 mm, length of the side. Draw an arc. Cut this horizontal line. Okay, radius as length of the side, that is 30 mm. Okay, so then connect these 2 points. Okay, next repeat the same procedure. You have 2 points. Okay, take this as center, draw an arc, radius is 30. Next, repeat the same procedure. This as center, radius 30, draw one more arc. Okay, next connect the points. Okay, so this is the easiest procedure. If you go for using protractor, again the chance of committing error is very less in this construction procedure. If you go for using protractor, you will end up with making mistakes. Okay, if you have a doubt, you can check. Okay, which one is easy and in which way you can draw this with less effort. Okay, you will understand by practice also. Okay, this is the procedure you should follow. Next, so I will make the sides thick. Only these 4 lines should be thick. Remaining all are construction lines. Okay. Next, so I will delete this. Okay, just I draw only because So they are required for construction. So you can draw them as thin line and you can retain them, no problem. But as construction lines, very thin lines. Okay. Next, I will name the points. A, B, C, D. Okay. Next, so I will. This is the top view. So I should dimension any one of the side. Okay. Out of 4, only one should be dimension. Okay. I will dimension one of the side. 30. Okay. Next, I will project the points in order to get the front view. Next, so I will draw front view by connecting this point to this. I will increase the thickness. Next, I will name the points. So this is A dash, this is D dash, this is B dash, next C dash. Okay, this is the front view. Now, so I have drawn top and front view by keeping the complete square lamina on HP so that I can see its true shape in top view and true length of the diagonal in front view. Next, I will satisfy the first condition, that is one of the diagonal. Okay, so here there are two diagonals, that is a line connecting D to B or B to D and A to C. There are two diagonals. Now this diagonal is parallel to both HP and VP. Now I will make it inclined to HP. Okay, on HP, CA on HP means, so it will be parallel to HP only. Okay, now I will make it inclined at 30 degree to HP. So next procedure is, so leaving convenient gap. Okay, so consider a point on XY line, that is A. Next, draw a inclined line, a line inclined at 30 degree. Okay, if it is resting on HP, so you should consider inclination with respect to HP first. If it is resting on VP, you should consider inclination with respect to VP first. Next, so this angle should be 30. First, draw a line inclined at 30 degree. Next, so take the points. So this is A dash. Next, we should measure the radial distance between A dash and D dash. So using compass, directly you can take the distance between these 2 points and you can mark it here, no problem. Okay, next, so I will use center point arc. That means you should use compass, center. Okay, then this length, this radius is 21.21. Next, so here also it will be same 21.21 only. So if you measure also, so you will get the same value 21.21. So once again from this point, so I will draw one more arc and 21.21. Okay, so I will get the required points. Okay, next, so I will draw a line between this point and this. Okay, this is the front view. Then I will name the points. So this is A dash, next C dash, B dash, sorry, not C, that is A, B and D. Okay, I will correct that. B dash, okay. Okay, this is D dash and B dash. After this, next project the points and get the top view. That is the next step. So I will project the points from here. C. Here it is. C. Okay. Next, D and B. A. So from here B. Next after that, so I will connect these points. So here also I should draw a projector. Project the points. Okay, next, so I will connect them. I will increase the thickness. Then next I will name these points. This is A, this is B, and this is C, D. Okay. So till here it is same as previous problems, except so it is resting on corner. Okay. Next step is very important, and the concept that we are going to discuss next, that is very important. Okay, that is applicable for projection of planes and also projection of solids. Okay, it is a very important concept. Now, so consider the given inclination. So inclination with respect to VP, 45 degree to VP. Okay, whether diagonal is inclined at 30 degree to HP and 45 degree to VP. Now we satisfy the first condition, 30 degree to HP. Now diagonal is inclined at 45 degree to VP. Whether it is true inclination or false inclination, 45 degree. Whether it is true inclination or false inclination. Okay, you should try to give answer. So 45 degree to VP, whether the given inclination is true inclination or false inclination. Okay, the given inclination is true. The reason is, so here diagonal is inclined at 45 degree to VP. Suppose instead of this, diagonal appears to be inclined at 45 degree to VP means that is false, appears. Or in top view, diagonal is inclined at 45 degree to VP means that is false inclination. If they use appears to be inclined or in top view, then only that is false inclination. Otherwise, it is true inclination. Simply if they give diagonal is inclined at 45 degree to VP, that is true inclination. Okay, 45 degree to VP is true inclination. Now in projection of lines, we know true length always associated with true inclination, false length always associated with false inclination. True inclinations are theta and phi, false inclination are alpha and beta. Okay, now we need to make diagonal inclined at 45 degree to VP. Okay, that means we should rotate the second top view to satisfy the last condition. But before that, check the length of the diagonal. Okay, earlier the length of the diagonal CA, it was 42, around 42. Now, because of the inclination, the length of the same diagonal, that is CA, got reduced to 36. Okay, so actual length of the diagonal was 42.43, around 42 mm. Now, because of the inclination, the length of the diagonal got reduced to 36.69 mm. That means here we have false length of the diagonal. Actual length of the diagonal, that is true length of the diagonal, is 42.43, but because of the inclination, we have false length of the diagonal. Next, we should make this view, that means we should make this false length inclined at false angle, not true angle. Okay, so here that means this should be inclined at false angle, but we don't know false angle. Now we should find out false angle. We know true inclination, we know true length of the diagonal, and also we know false length of the diagonal. Unknown is false angle, that is false inclination beta. That we should find out. For that there is a procedure. Okay, that procedure I will explain. First, draw a line. Okay, so you can start from xy also, no problem, or you can draw a line parallel to xy and you can start from there. Okay, I will draw a line parallel to xy. Then first you know true angle, true inclination and true length. Okay, first draw a line, inclined line, true inclination and to true length. Okay, true inclination is 45 degree. Draw a line inclined at 45 degree and having length, true length of the diagonal. That means take radial distance between A and C, A to C, this distance using compass. Okay, then draw this to that length, that is 42.43. Okay, next. So after drawing this, so this is a fixed point A. Okay, I will consider this as A. Next, so I will draw the locus of this point. So draw a locus, a line passing through this point. Okay, now I will delete it. So I have drawn a line inclined at 45 degree and having true length, that is 42.43. That is this line. And immediately I will draw a horizontal line, that is locus of this point. Now I know false length of the diagonal AC, but I don't know angle. Now what I do? So I will measure the false length using compass. Okay, take 2 points on this view, A to C, using compass. Okay, fix the tip of the compass to A and tip of the pencil to C. Take radial distance. This is A center, cut an arc. Okay, now I will use center point arc. This as center and false length as radius. I will draw an arc. False length is 36.69. I will draw an arc. It will cut this locus at a certain point. Okay. Then join this fixed point A to this point. Okay. This is having false length. Now the angle between this horizontal line or xy and this inclined line is beta, which is 56 degree. Okay, 55.99 means it is 56. Okay, there is a if there is 1 or 2 degree variation, okay, need not worry, that is acceptable. Okay, since it is graphical method, there will be some error, so we will accept if there is a deviation of 1 to 2 degree error. Okay, need not worry about that. So 56 degree is the beta, false inclination. Okay, now this view, the second top view should be inclined at beta. Okay, that means this should be the diagonal of of this view. Okay, now so I will name it as, this is A fixed point and this is C. So now I should get remaining 2 points, that is B and D. Okay, so if you have any doubt regarding this, you can ask. So ಏನಾದ್ರು ಅರ್ಥ ಆಗಿಲ್ಲ ಇದರಲ್ಲಿ ಅಂದ್ರೆ ಕೇಳಬಹುದು. Okay, if you have understood, I will continue. Okay, now so A and C already known. I should get remaining 2 points B and D. Okay, so measure the radial distance between A and B. Okay, you should use compass. Okay, take radial distance between A and B using compass and mark, cut an arc. Okay, first I will measure this radial distance. Next, so I will use the center point arc command. A as center and this 28.27 as radius. I will cut an arc. Okay, next C to B also, it will have the same radial distance. Okay, if there is no error, it will have the same radial distance. Here, because of error, I am getting a different value. Okay, need not worry. So if your construction is correct, so it will have same radial distance. Okay, next, so C as center, I will draw an arc. Okay, radial distance will be same 28 point. Okay, next, so this is point B. Okay, similarly I should get point C. Okay, again radial distance will be same, it will be 28.27. If you measure also, you should get the same value. Okay, it will be 28.27. Next, so A as center, again same value. I will draw one more arc. It is 28.27. Okay, so next, so I will name these points. So this is B and this is D. Okay, so after this, so you can connect the points. Connect A to B, then B to C, C to D, and D to A. Okay, this is the same view in a different orientation. Okay, so next, so after drawing this, so you should get the final view. So by projecting points, so you should get the final view. So this is B. Okay, B to B, then C, C to C, then A, it is on the XY line, so till here. Next, okay, so afterwards, so you can name the points. So this is A dash. Next B dash, since it is front view. Next C dash, B dash. Sorry, this is since here D, it is D dash. Okay, and this is B. Here it is B, so it is B dash. Okay, after locating the points, so connect them using scale. Draw straight lines. So A to B, B to C, C to D, then D to A. Then select these lines, increase the thickness. This is the final. Okay. So if you have any doubts regarding this, you can ask questions. So I will try to clarify your doubt. Okay. If you don't have any doubts, so I will move on to next problem. Okay. So this is the problem which we solved now. Okay. Later I will share this solution. So you should draw it as classwork too. Okay. Next I will consider last problem of today's class. A circular lamina of 50 mm diameter rests on HP such that one of its diameters is inclined at 30 degree to VP and 45 degree to HP. Draw its top and front views in this position. Okay. So here given lamina is circular lamina. There is a difference between remaining polygons and circular lamina. Okay, in case of polygons, you will have predefined corners, whereas in case of circular lamina, you don't have these corners. So for construction purpose, we will divide the circle into number of equal parts. This is just to define the boundary of the circular lamina. We are going to divide the circle into number of points. Okay, that is one thing. Next, given lamina circular lamina, it is having diameter 50 mm, rests on HP such that one of its diameters is inclined at 30 degree to VP and 45 degree to HP. So here we can, so one of the diameter, so that means, so we can consider any of these lines, we can consider n number of diameters. So here I will consider a diameter which is parallel to XY line so that I am able to see its, I am able to represent its true length in front view. Okay, I will consider AE as the diameter. Okay, so in front view, AE, it will have the same length, true length in front view. Okay, next, inclined at 30 degree to VP and 45 degree to HP. So here in the question, 30 degree to VP is given first and 45 degree to HP is given second. Which one we should consider first? Whether I should consider 30 degree to VP first or 45 degree to HP first? What is the criteria for that? So that we discussed in
45 degree to HP.
45 degree to HP. What is the reason?
Sir, because the circular lamina rests on HP.
Yes, okay, it is very important. In this question, so 30 degree to VP is given first. Okay, don't get confused. If the lamina is resting on HP, whether inclination with respect to HP is given second or first, okay, that should not be considered. If it is resting on HP, inclination with respect to HP should be satisfied first, and that is a laminar inclination. Okay, then we go for inclination with respect to VP. Since here also it is resting on HP on its diameters, okay, we are going to consider 45 degree to HP first. then we will go for 30 degree to VP. Suppose if it is resting on VP instead of HP, then we used to take this 30 degree to VP first. But here we should consider 45 degree to HP because it is resting on HP. Okay. Next, so initially concepts are same. Okay, only in order to for construction purpose, we will divide circle into number of equal parts and we will take a few points on the circular lamina. Other than that, remaining concepts almost same. Okay. First, I will keep the complete circular lamina on HP so that I can see the true shape of the circular lamina in top view. Then I will project the points and I will get the front view. Since it is resting on HP, I should consider inclination with respect to HP first. So I will take the front view. I will redraw the same front view in different orientation. That means I will draw it as a line inclined at 45 degrees. Same front view, which is a line. I will redraw it such that it is making 45 degree inclination with XY. That means it is making inclination with HP. Then I will project the points. I will draw this. Okay. So I will construct these two steps. Then I will explain the remaining thing. Okay. I will consider the same problem on SolidWorks. So first I will draw XY line. Okay, next, so I will start from top view. So using compass, so draw a circle having diameter 50. That means radius will be 25. Okay, so after drawing circle, so in case of pentagon, hexagon, square, rectangle, triangle, you will have a fixed number of corners. So, but on circle, you cannot find a corner. Okay, but for construction purpose, we need to define the boundary, and for projection, we are going to consider points. So that's why this circle should be divided into 8 equal parts, so that we are able to define boundary with the help of these 8 points. Okay. In order to do that, so first draw horizontal and vertical line passing through the center. Okay, first draw horizontal line and vertical line. Okay, passing through the center. So first I will draw the horizontal line. Next I will draw vertical line. Okay. Next, so now I am able, by drawing one horizontal line and one vertical line, I am able to divide the circle into 4 equal parts. But 4 points are not sufficient. Okay, I should get minimum. I should get 8 points. Okay. Next, use your protractor. Okay, measure 45 degree. Okay, or you can bisect, but that is okay. That will take more time. So use protractor. Okay, get this point. So mark 45 degree angle from this line and connect them. So you will get this point. Okay. So first divide circle into 8 equal parts like this. Okay, first draw vertical and horizontal line. Next, using protractor, so draw lines 45 degree inclined lines so that you will get these points. Okay. Next, after dividing circle into 8 equal parts, name them. Okay, so these lines, they are construction lines. Only this circle should be thick, remaining should be thin. They are construction lines. Okay, now I will name the points. Okay, so after this, draw a line. So draw projectors to get the front view. That means vertical lines passing through these points. They are the projectors. Okay, so next, so I will draw a line between these two, and this is the front view. Okay, then I will name the points. So this is A dash. So here also, this is the position of the observer. He is looking from this direction. That means A, H, G, F, E. These points will be visible. That means half portion will be visible from front. Remaining half, which is on the rear end. So this B, C, and D, these 3 points are invisible. Okay, H dash visible, B dash will be invisible, G dash will be visible, C dash will be invisible. Next, F dash will be visible, D dash invisible. So here E dash will name the points. Okay, so this is the front view. So here I should dimension the diameter. Okay, so that is 50. Dimension it. Next, so draw an inclined line. So 45 degree to HP. So here you can see this is the 50 mm is the true length of the diameter. Okay, so see here A to E it is also 50. That means we have true length of the diameter. So 45 degrees to inclination, we have true length of the diameter. So same front view can be written inclined at 45 degree. So first draw a line inclined at 45 degree. Okay, next take these points. So using compass, so measure the distance between AH. This is A and cut the arc. Next again use the compass, measure distance between A and G. A, G, cut an arc. Next measure distance between A, F, A, cut an arc. Next measure distance between A to E, cut an arc. Like that we should get all the points using compass. Okay, since it is at the center, it will be 25. Okay, so now I will use center point arc. That means you should use compass. The radius is 7.32. Next, so again A center, so 25 radius, 25 mm. Okay, next, so I will measure the distance between A and this point. So it is 42.68. Okay, next, so this will be 50 from A to E, it is 50. So A to E. Okay, next, so I will draw one more line and I will make it thick. Okay, remaining you can erase, or you can, if they are very thin, you can leave it as it is. If they are thick, you should erase remaining construction lines. Next, I will name these points. So, dash. Okay, next, again same procedure, project the points from front view and from top view and get new points for second top view. Okay, I will project the point E, and here it is E, this is point T, similarly F and D. Okay, from here also you should project C till here. Let's see. Next, D and B. Okay, after that you can name the points. So this is A. Next, B, C, D. Like this you should name the points. Okay, so after this, so you should connect all these points with free hand. Here you should not use scale. So for previous problems, so you were using scale to connect because those are polygons and they were having edges, but it is a circle. Because of inclination, the circle will look like ellipse. That means you should connect this with smooth curve and you should draw this curve freehand. Okay, without using any instruments, you should connect these points. Okay, I will connect from A to B, then B to C, C to D, D to E to F, F to G, G to H, and H to A. Like this, you should start from A, go on connecting all the points with curve and complete it. Okay, you should get ellipse like this. Okay, this is the second top view. Now we should satisfy the last condition, that is one of its diameters is inclined at 30 degree to VP and 45 degree to HP. So we are considering AE as that one of the diameter AE, okay, and we satisfy one condition, that is 45 degree to HP. So AE, A dash E dash is inclined at 45 degree. That means 45 degree to HP is already satisfied. Now we should satisfy the last condition, that is 30 degree to VP. Now once again we should incline this ellipse to some inclination with VP. Now you should check whether you have true length of the diameter or not. Okay, so 30 degree to VP, whether it is true inclination or false inclination. Whether it is true inclination or false inclination. So it is true inclination. given inclination is true because see here, one of the diameters is inclined at 30 degree. That means diameter is inclined at 30 degree means that is true inclination. Instead of that, if they use diameter appears to be inclined at 30 degree to VP, that is false. Appears means actually it is something else, but it looks like means appears. Okay, that is the way of representing false angle. And one more way of representing false angle is in top view, diameter is inclined at 30 degree to VP means that is false angle. Here they have not used appears to be inclined, and also they have not used diameter in top view. Okay, so without referring to view and without using the term appears, if inclination is given, that is true. Okay, here 30 degree to VP is true inclination. Now we should check whether we have true length of the diameter. Okay, initially it was 50. Now because of inclination with HP, okay, so measure the length of this diameter. So it is 35.69. That means the length of the diameter got reduced from 50 to 35.69. That means we have false length of the diameter. Okay, so given inclination is true, we have false length of the diameter. That means we here also we should find out beta. So again I will follow the same procedure. First I will draw a line at a convenient distance. I will draw a line parallel to XY. Then I know true length of the diameter, that is 50, and also true inclination, that is 30 degree. So I will draw a line inclined at 30 degree having length 50. Okay, and this length should be 50. Now, so this is point A fixed. Now I will draw locus of this point, draw horizontal line. Okay, next take the false length and cut the arc. Okay, so this is center and false length of the diameter as radius, that is 35.69 as radius. Cut the arc. Okay, it is cutting this point. Next, connect this point to this using scale. Okay, next measure the angle using protractor. Angle between this line and this. So it is 45 degree. 45 degree is the false inclination. Okay, to which this should be inclined. So we determine beta. Beta is 45. Okay. Next. So this is point A. This is E. Next, I should get remaining points. So AE already on this line. I should get B, C, D, and also F, G, H. Okay, first I know A, point A and E. I should get C. Okay, I know A and E. I can get G using compass. Okay, first I will measure the radial distance between A to C. That is 30.72. Okay, radial distance between A to C, C to E, E to G, and G to A. So all four are same. Okay, now I will consider the radial distance between A to C using compass. So A as center and C as radius. Okay, I will draw an arc. So radius is 30.7. So I will draw an arc. Okay, next again E as center, again same radial distance E to C will be also 30.72. So I will draw an arc. .72. Okay. Similarly, So on the other side, that is, in order to get G, again radial distance will between A and G will be 30.72. So I will draw an arc from A as center and A to G as radius. So that is 30.72. Okay, next E to G as radius. It is also 30.72. Okay, I will draw arc. Next, so connect the points. So this is point C and this is point G. Okay. Now, so we have point G, A, C, E, 4 points. Okay, we should get remaining 4. Now I have point A and C, I should get B. Okay. Now I will consider the radial distance between A and B, radial distance using compass. So that is 18.37. Next, radial distance between C to B, 14.79. Okay, I will consider these two radial distance. Now I know A and C, I should get B. From A, I will draw an arc considering radius as distance between A and B. Radial distance between AB is the radius and A is the center. I will draw an arc. Next, so C to B, radial distance between C to B is the radius and C as center. I will draw one more arc. So 14.19. Okay, so I will draw an arc. So this is point B. Okay, so this is point B. Next, similarly, so I know point C and E, I will get D using same method. From C to D, so it is same 14.79. Next, from E to D, $18.37. Okay, next, so I will get point D. Okay, similarly, I know point E and G, I can get point F. Okay, from E to F, so E to F, it will be 18.37. It is radial distance between AB, ED, EF, AH, all are same. Okay, similarly, radial distance between BC, CD, FG, HG are same. Next, so G to F, so G as center, G to F, it is 14.79. Okay, next, similarly, I will get, so point H. I know G and A, I can get H. From A, so radius will be 18.37. from G, radius will be 14.79. Okay, so this is point H. Okay, now I will mark these points A, so this is B, then C, this is D, E, this is F, E, this is H. Okay, next, so after this I will connect the points again using freehand. Okay, using hand without using any instrument, you should connect A to B, A to B, B to C, C to D, D to E, E to F, F to G, G to H, H to A. So like this you should connect. Okay, so I think there is some error, some points. Okay, I will check. G. Okay, so I will check. So there is some mistake. So this radial distance, this should be 18.37. That is 14.79. Okay. Okay, so there is some problem in this point. Okay, so I will retry it. Okay, so I will consider from E. Okay, I am getting F, so E to F, so it will be 18.37. Next, so G to F, so it is 14.79. Okay, so this is point F. Okay, next, so I will connect all these points. So if you connect freehand without using any instruments, so A to B, B to C, C to D, D to E, E to F, F to G, G to H, and H to A. Okay, like this. Then I will increase the thickness. Okay, so same view in a different orientation. That means here AE is parallel to XY. So in this view, same AE is making beta inclination, that is false inclination, that is 45 degree with XY. Okay, so next, so you should get the final view. So in order to get these points, so initially by using beta angle procedure, so I will get this line. I can get AE. I will mark AE on this line. Next, so if you know points A and E, using compass, you can get point C. Okay, I did the same procedure. Using compass, I got C. Similarly, using compass, if you know E and A, you can get G. Okay, E and A, you can get point G. Next, so if you know A and C, you can get point B. So I know A and C. Again, using compass, I can get point B. So take radial distance and cut arc and get the point. Similarly, you can get D, F, and H. Okay, so after this, I will project the points and I will get the final view. So A, so it is on XY, so till here. Next B. C. Next D. Next F. G. Next H. Okay, next, so after that, so name the points. So A dash, so this will be A dash. B dash. Next C dash. Dash. Next E dash. I just name all the points. So later again using freehand connect the points. Start from A then move from A to B, then B to C, like that. A to B, B to C, C to D, E, F, G, H, again back to A. Okay, so this is the final front view. So this is the view of the circle when one of the diameter is making 45 degree with HP and 45 degree, that is beta angle with VP. Okay, this is the final front view. Okay, if you have any doubt regarding this, you can ask questions or doubts. Okay, so I will post one more class